do rates of change, which there's not a lot to talk about with that. But let's review this. This is old. We did the max-min existence theorem this week. We talked about continuity and limits. So show that f is continuous. Well, to do that, how do we do that? Remember the 3 steps? First, you find out what f of c is because it must exist. It's only 2 points, but I think it's easy. Usually question 6 is one of the hardest ones on the exam, but for some reason this one doesn't seem that bad. I mean, you have to know what continuity is, but we've talked about that. 75% of you will get this right. You don't get the joke, remember? I told you it was a test question. Remember we had this as a test question, and we told you and told you and told you, but still 25% of the people got it wrong? Shouldn't get it wrong. What's got to be true about the limit? As x approaches c of f of x, you must use correct notation. You going to work back there, Adam? Must exist. Okay. And what's the final step? Yep, the limit as x approaches c of f of x has to equal f of c. So I would find f of c first. And we'll look at what the answer should be. So f of c, what's c? 0. So what's f of 0? Which equation will you use? Top one. So 1 minus 2 times the sine of 0 is 1. Okay? How about the limit? The limit as x approaches 0 from the left, which equation will I use? Top one, 1 minus 2 times the sine of x. What's that equal to? 1. Is this hard? No. And the limit as x approaches 0 from the right, we've done lots of problems like this. And I'm going to use e to the minus 4x. And you're going to have to evaluate it because you're not going to know if they're equal. And so it's e to the what? 0. What's any number to 0? 1. I'm not done because I have to justify this. And I would say the limit as x approaches 0 of f of x equals f of 0. And if I really want to be careful and make sure I'm going to get all my points, I would put 1 equals 1. I don't get points for the smiley face, though. It's the second function. It's e to the minus 4x. Because to do f of 0, I do the one where it's the function where it's defined for 0, and it's defined for 0 here. Had it been x less than 0, x greater than 0, then you would say f of c does not exist. F of 0 does not exist, therefore it's not continuous. And we did problems like that. So this is very similar to what we've done. Let's check our points. I think we should go ahead and do this whole problem. Okay? You get 2 points. You've got to show all the work. Notice I took both limits, clearly showed from the left and the right. I found the value of the function, and I said that they're equal. So not too bad. But make sure it's clear, because we cannot assume anything. Okay? Next part. Oops, wrong one. We'll do that one too. Okay. Express f prime as a piecewise function. Well, I'm just going to take a little picture of this. And it's not that bad. Whoops, I don't want that. I don't think it's that bad. Okay, what's f prime look like? Okay, girls, what's f prime? So f prime of x, you don't necessarily have to put it in these fancy little braces, but it's kind of nice. And this is for x less than or equal to 0, x greater than 0. Now all we have to do is find the derivative. I took this problem and rewrote it as a pre-calculus problem. It could have asked you, is it differentiable at 0? Well, first thing you have to check is for continuity. So then they say find the derivative. Now, when you graph this, it's not a graphing calculator problem, but it's kind of interesting when you do the piecewise function. They do meet up nicely. However, the slopes are ever so slightly different. And it's very subtle to look at it graphically. Easier to probably do it algebraically. What's the derivative of the first one? This is not hard. -2, the derivative of the sine is cosine of x. And e to the minus 4x, what's the derivative of that? E to the minus 4x times -4. That's all they asked. Express f prime as a piecewise defined function. Find the value of x for which f prime of x equals -3. Okay, so for x less than or equal to 0, I want -2 cosine of x equal to -3. I don't know which function to use. So the cosine of x is equal to 1.5 or 3/2. Is that possible? What's the biggest cosine can be? 1. No, not possible. But I want to check everything. Okay, so that's fine. X obviously has to be greater than 0. Or maybe it doesn't. I don't know. I don't remember. So if x is greater than 0, I want -4 e to the -4x to be greater than, what was it? Or equal to, is it? No, sorry, equals -3. It's right here. This is my piecewise function. I just take the derivative of each piece. Yeah, don't make it hard.
We show that last step where we have to show the -4.
Well, x less than 0 doesn't work. We still have to do this one. This one does work. We have to solve for x. So what should you do first? This is pre-calculus now. This is not calculus. Divide by -4. That's right. So I'm going to get e to the -4x equals 3/4. You know, and it's not a calculator problem, so I have to do the work. And then Artavan says we should take the natural log of both sides. And everybody should be involved. Even though you think you know how to do this, then beat me at it. That's even better. Do you remember your properties of logs? What happens to this? It comes down in front, -4x times the natural log of e, and hopefully we know what that is, equals the natural log of 3/4. What's the natural log of e? That's 1. So -4x.
It's always just 1.
That's correct. It would be safe to just not write that. But just for everybody to make sure they're right. And then what do? Divide by -4. Or multiply by -1/4. The reason why I'm doing this is because some of you are going to have a hard time over here. How do you multiply? How do you do this? Oh, but I can't do it anyway. So x is equal to the log of 3/4, I forgot the other half of my parentheses, divided by a -4. Well, the negative can be in front. Whatever that value is, I don't know what it is. Should we see if we did it right? I haven't done this problem. What year is this? Last year's. I've only done this problem once. Okay, there's my derivative. 2 points for f prime, 1 point for that one, 1 point for that one, and 1 point for the value of x. There it is, -1/4 log of 3/4. It's the same thing. Could you have also written it this way? Okay, it's going to be fussy. You could have written it as x equals the log of 3/4 divided by -1/4. We don't care. So if you don't know how to simplify it, it's good enough. Okay, so how many points do we have? Okay, the first one, we can do that. That's 2. This isn't hard to get these derivatives. Everybody in here should be able to get these derivatives. They're really basic. So that's 2, so now you're at 4. And some of you may have some problems with this, so we might miss that one. Depends how good you are with the pre-calc. Oh, it's times 1/4. Right, it's divided by 4. Whoops, sorry. So what happens when you try to shortcut? Oh, it's still working. There you go. Yeah, I just wrote it wrong.
Do you have like separate packs for the calculator and non-calculator, or do you just?
1, 2, and 3 are calculator problems, and 4, 5, and 6 are not, except for last year.
But do they stop you?
Yeah, you put your calculator away. So what's going to happen is you'll take the calculator part first, and then you will put your calculator away, and then you'll continue. So you're going to get a half hour for the calculator part. You may go back to the calculator part during that hour, that next hour when you're working on the other 4 problems. So let's say you do the other 4 problems, say, okay, I've done that, I got 15 minutes, I want to go back and look at the calculator problems. You may do so, you just can't get your calculator back out. But the calculator part is probably only 1 point.
You just move on whenever you want to.
You're given a half, no, you're given a half hour. You cannot move on to the non-calculator part. But when you get to the non-calculator part, you can go back and forth. I like the non-calculator part better. Okay, whoops, wrong direction. Oh, now I know this isn't part of the lesson today, but you guys remember what the average value of a function is? We're going to do rate of change today, Andrew. This is average value. That's right. So the average value of f is the integral, and we got to be really careful with this. It's the integral from a to b of f of x dx divided by b minus a. You have to do the entire integral on this before you divide by the 2. So what am I trying to do? I have to integrate this function. So I'm going to integrate. Okay, I'm going to copy this thing here. Yes, I have to integrate both equations. And let me just write it up as a single thing. Hold on, I'm going to push this down. Whoops. So we're going to integrate this. And we want to go from -1 to 1. So we have to break it into 2 parts. We have to integrate from -1 to 0, 1 minus 2 sine of x dx, and then we have to integrate from 0 to 1, e to the minus 4x dx, and this whole thing we divide by 1 minus a minus 1. So I don't divide this by 1 and this by 1 and then add them. You have to add all the integrals together first and then divide by the 2. That's the tricky part. Is that okay? What is the antiderivative of the first one? I'll do them in different colors. So this is negative. Whoops, I got to integrate it. Sorry. What's the antiderivative of 1? X. Now, I always have problems with this. What's the antiderivative of sine? It's cosine of x. Now I check. Derivative of cosine is negative sine, so I'm going to have to put a plus there. Does that work now? I always check it. Whatever works for you, it doesn't matter to me. And this is from -1 to 0. It's over 2. Because you have to find all the, you have to do the integral from -1 to 1 divided by 1 minus a minus 1. So to get this integral, I got to divide it into 2. That's tricky. I think I got that wrong the first time I ran into a problem like this. Okay, can we do this one without a u substitution? Can we just do guess and check? What's wrong with guess and check? What's the antiderivative of e to the minus 4x? E to the minus 4x. Now that when I take the derivative, I'll have a -4 out in front. So I don't want that -4. So what do? Divide by. Now check, does that work? Do I need to use the quotient rule? No. Between what? 0 and 1. All over 2. Yes, you must continue. Unfortunately. So I've put in 0. I'll go back on my colors. Maybe. So this is 0 plus 2 times the cosine of 0. Minus a -1 plus 2 times the cosine of -1. That's not going to be nice, but that's okay. And that's for the black one. I hope I did it right. You guys check. Always check me. plus, and it's a negative 1/4. And let's go ahead and substitute this in. 1, so it's e to the negative 4 minus e to the 0. Right? I think I did that right? All divided by 2. And I believe you get your point here. We will simplify as much as we can. What's the cosine of 0? 1. So this is going to give me 2 plus 1 plus 2 times the cosine of negative 1. You know, cosine is an even function. I know you don't think this way, but you know what the cosine of negative 1? That's equal to the cosine of positive 1. Thank you, I missed a sign error. Made a sign error, that's why you don't want to simplify. It's a minus, because a minus times a plus is a minus. And then this is going to be minus 1/4 e to the negative 4. I mean, there's not much I can simplify. And then minus 1/4 times a minus 1 is plus 1/4 all over 2. Okay, let's see what they have, because it's a non-calc. It's 2 times 1 plus the 1. Yep. I want to see if it's right. Don't you? Okay. We have to integrate all that stuff. See, it's ugly. They combine this. Where do they divide by the 2? Oh, I could be wrong on that.
Why?
I did my integral right. But because it's the average value of the function. They don't divide by the 2, though. Wait, am I reading the question right? I think I'm reading the question right. I have to double check on that. I'm pretty sure I thought we had to divide by 2, but they don't make a mistake on the scoring rubrics. So if anybody's wrong, it's me. So I would lose a point. I guess they divided, I guess they did this. But see, that's that integral. That's correct. Oh, you know what? I'm missing a part. Then on, what year was this? 211 number 6. I bet I cut it off when I copied it. Because I don't think I'm wrong. Now you guys know that all this stuff is out here. Whoops, too far. Yeah, I cut it off, you guys. Whoops. Thought I was right. I make mistakes. Okay. We did the integrals correctly. There's the integral, and then I copied that. You have to do 1/2 of the total integral, so you just divide by 2. My answer is fine. All 9 points. So you get 1 point for writing this. Just writing this. 1 point for 2 points. 1 point for each of your antiderivatives, and then it's only 1 point for the final answer. You get 8. You're doing great. Okay. Let's just quickly review rates of change. What is a rate of change? It's a ratio of 2 changes. I could put the clock up, but it kind of get in the way. We're doing fine. Okay, you guys? Rational expressions are fractions. And guess what? There's ratio in that. Okay, guys? A ratio of 2 changes is a fraction. And guess what? I can see ratio in there as well. There's ratio. I don't know if that's by accident. Probably not. It probably comes from the Latin. So a rate of change is a ratio of 2 changes. So I'm going to draw a picture of a graph. It won't be as pretty as my other class, probably. Ooh. And we'll call that A. We'll call that B. And I'm going to draw this secant line, which is the average rate of change. Zach, question? Okay, guys. Natalie? The slope between these 2 points is the average rate of change. And we've talked about this already, so this is nothing new. What is the average rate of change? It's F of B minus F of A. You could do it the other way, that's correct, over B minus A. That's all it is. If I drag this point here, and I drag this point closer, whoops, wrong thing I grabbed. Closer and closer to my A value, then I'm going to look at the instantaneous rate of change. That's too long a word. Now I'm going to use this form of my derivative because it doesn't hurt for us to see this. This is the limit of f of b minus f of a. And algebraically, sometimes this is an easier limit to find, sometimes not. And what's happening? H isn't going to 0. What's happening? B is going to where? B is going to A. There's really not much to talk about this. We'll just do problems. We'll do the snowflake problem next so we get in the same place. Okay. And the problem is when you read the problems, okay, guys, there is a connection between average rate of change and average value of a function. I'm not ready to make that connection today. I mean, I'm ready, but I'm not the right time. But you remember the average value of a function. We just did that. It's what? The integral of the function from a to b of f of x dx divided by b minus a. Okay, Adam, look at the words here. It's so easy on the exam, Natalie, to not read it correctly. Average rate of change, you have to read every single word. This is average value of a function. Do you see how you could actually, yes, can you see how you can actually mess that up and do the wrong thing? Okay, so you have to read carefully. So, huh? It is, and it's not like English reading. Now, yesterday, we started this problem, didn't we? Yeah. I thought we did. Well, those of us who were involved. Yeah, we started that problem. Ah, darn. I don't know where this is. Oh. Oh, that's okay. Oh, there it is. Never mind. So, we'll finish with that problem. Let's do the snow removal problem. Now, this is 2010, I believe.
I don't think you fully understand.
You have it, but I'll give you another copy so you have room to work, because I have it.
Oh, there goes the donut.
They didn't come to sell us donuts, did they? Okay, and then we'll finish up with the other problem, but which we hopefully will finish. We'll see where we get. And there's probably some multiple choice questions also that have rates of change. Just read the problem carefully. Now you guys know on the exam, you're either going to find a derivative or an antiderivative. You're going to need your calculator for this problem. This is, I believe it's 2010. Yeah, I don't know where my calculators are. There we go. 2010. Question 1. You know, and when you start looking at these and you get into them, you go, well, they're not so bad. But when you first walk into the exam, they're kind of scary. So we call this the snow removal problem. I graded this problem. That was 2 years ago, so I'm not sure I really remember all the details about what went wrong. I believe that the average was somewhere around 3 out of 9. Okay. No, you all have numbers. They have numbers. I don't even know the schools. But what they do is they get grouped together, usually like 5 schools together at a time. But they usually can tell even the teaching style of the teacher. Yeah, it's kind of interesting to see that. And finally you go back and look, oh yeah, it's all the same school. So I don't always know where the school's from. Okay, so this is a problem. Now, if you live in Hawaii, this problem might be hard for you. But does it snow in Hawaii? Not often. Where does it snow? It does. They have mountains. Okay, I know I keep thinking, well, it never snows in Hawaii, but most people probably never really encounter snow there. Getting back and forth between the islands is very, very expensive because they're not allowed to use boats, so they have to fly. And so flying is like going from here to Chicago. Yeah, it's ridiculous. Okay, there is no snow. Now you gotta, because of the fish.
You can for some
Yeah, but mostly they fly. The whales and stuff. I suppose, but they're not that close together. Okay, guys. You guys, let's get this done. There's no snow on Janet's driveway. Now you have to just back off the calculus and think about what's happening here. Snow begins to fall at midnight. That happens to us in Minnesota. Not this year, but previous years. From midnight to 9 a.m., the snow accumulates. An integral is an accumulator. When you see total or accumulates, you're talking about an integral. It's not a rate of change. And I can't separate the problems, unfortunately. Okay. And the rate at which the snow is falling is modeled by this function, cubic feet per hour, where T is measured in hours since midnight. Janet starts removing snow starting at 6 a.m., and the rate at which she's removing the snow is given by this little function here, which I might as well take a picture of it right now because I'm going to need it. This is a calculator problem. Don't know why I was looking by there, but that's okay.
Once it accumulates, we should probably do a sum.
Yeah, you're going to add up all the snow, and we do that with an integral. So if you take the cubic feet per hour and multiply by the number of hours, you know, you're going to have it all, right? But it's changing. It's modeled by this little function here. So the first question is, how many cubic feet of snow accumulates by 6 a.m.? So what are we going to do to f of t? We're going to integrate it. It's perfectly allowable to write it down like this, from 0 to 6. Now I'm going to get my calculator out. I suppose I got to do this, right? You cannot integrate it by hand. I haven't taught you how to do that. It's integration by parts. So if you get your calculator out and try it, I'm going to see if I can actually switch this. That's a slope field that you can put on your calculators. But the slope fields questions will be without in the non-calculator section. So I'm going to go into my mode and see if I can switch this back to classic. If you want the new operating system, you just have to let me know. We'll do auto. That should work. Now also when I go to mode, make sure that you are in Radian mode. And even on Monday and Tuesday before the exam, Mrs. Hersman, Mr. Dahman, and I will be reminding you to switch to Radian mode. And I know in science you're in degree mode. That's a problem. We try to get to all the rooms Wednesday morning. But once they start the exam, they won't let us in. So we will do our best. Well, you might see us, you might not. But we will remind you again to go to Radian mode. Okay, so I'm going to clear that out, and we want to integrate that function. I find it easiest to put it into y1. And that was, I don't want to do that, y equals. And I'm going to clear that, and you guys should be way ahead of me. Now, the 2 isn't important, but I'll go ahead and get rid of it. It's 7t. Now, does it matter if I use x or t? No. And it's e, second log. And I want cosine of t, or x. Okay. Clear that out. Now, remember where integrals are? Math. Do you remember where? You can go up, you know. It's 9, FNINT. If you have the new operating system, you get to it much faster than that. I want to get y1, so it's bars, y variables, function, y1, comma. Then you tell the variable we're working with, which is always x, comma, and we're going to go from 0 to 6. Now, I'm going to come back and grab this again later on in the problem. There it is. That's correct. When in doubt, leave all the decimal places. Now, they don't care about this FNINT. They care about this piece right here. You get 1 point for that, and you get 1 point for that. So if you're in the wrong mode, you're going to lose that point. That's what's going to happen. That wasn't too bad. We had 2 points already. Okay, find the rate of change of the volume of the snow. I want to know how fast the volume is changing. So, what do you think? That's it. No points. If you only do the calculator notation I have over here, you will get nothing out of 2. They won't even give you the 142. Correct. Because you do not have this part. You need to have the calculus part. Okay, guys? So, I want the volume of the snow coming down, that rate, minus the volume that she's removing. Does this make sense? That'll tell me how fast the snow is accumulating. Because it's snowing and then she's shoveling all at the same time. And it says, find the rate of change of the volume. So I want to see how the volume changes. Okay, so and now what time is this? 8? So I want f of 8. Okay, guys? F of 8 minus, the removal rate was g, right? G of 8. That's sufficient. So what is f of 8? So how are we going to get that? That's good enough. You can put the numbers in if you want, but you can just state that. Let's get back to our calculator. There's easy ways to do this, and here's an easy way to do this. Now my f of x, or f of t, is into my calculator in y1. So I'm just going to pull it out. I'm going to clear that. It's still there, though. Bars, and I want to pick up my y variable, and I want to evaluate that at 8. Enter. So it's easy. Don't write more than you have to write. Okay, so it's going to be this 48 minus g of 8. Okay, what's g of 8? G of 8, whoops, is 108. You see that? Okay, you guys, front table? Should you find out what g of 8 is? G of 8 equals what? 108, right? So it's minus 108. And that's probably a good enough answer. But everybody simplifies it. You have a calculator. And so we're going to do minus 108. I would not do it by hand. I would let my calculator do it. And that's the correct answer because I remember it. No, I didn't do y1 times 8. I did y1 evaluated 8. It's function notation. What a nice way to introduce that to algebra students when they start getting into function notation, because the calculator does it already, so it will be an easier transition. Pardon? Question? No, if they don't say anything about units, if you put them in and you do it wrong or you do it right, we don't really care because we won't look at them. If it does ask for units, just always reread your problem before you turn your test in if you're done early. Did it ask me for units? No, it did not. So I'm not going to put units in. I'm not going to waste my time. I could. Okay, now C was the problem. This is the problem right here. We were okay to that point, for the most part. Find the, it says C, let H represent the total amount of snow in cubic feet that Janet has removed from the driveway. Express H as a piecewise function from 0 to 9. Now G is how fast she's removing it. So that's a rate. I want to know how much she has removed. Well, I kind of like the table, but you don't have to do it in a table, but it's kind of nice. So H of T, well, and when I show you the answer key, it's really ugly. It's much easier than that. How much do you remove between 6 and 0? This is C, I think. You remove nothing, and guess what? A lot of students skipped that one. They just totally skipped it. You got a point for writing 0. Okay, maybe you can't do the other two pieces, but that's okay. You get the point for the 0. So don't skip anything. Try something. Now, here was the tricky part. Between T is between 6 and 7. You're removing it at a rate of 125 cubic feet per hour. I know you want to say that's 125, but what if it's 6:30 a.m.? You have not removed 125 cubic feet. How much have you removed? Half of that, right? Because only halfway through. If it's 6:45, you have removed 3/4 of it. So I have to integrate this. I don't have to integrate it really, but I will. Starting at what time though? Not 0, 6. This is the safe way to do it. And I don't know what I'm going to end up with in my time. I just know time's less than 7. But let's call it T, where T represents any amount of time between 6 and 7. Then this is 125 dx dt. I don't care what you call it. And so if I integrate that, this 125 x evaluated at 6 and t, so it's 125 times t minus 125 times 6. Can I factor out 125? Sure. And it's t minus 6. That's what goes in here. Could you have done it without an integral? Sure. But what you have to do is you can't start multiplying by t because t starts at 6. And at 6 a.m. she hasn't removed any snow. So that's not going to work. You have to do a translation. You have to think of shifting it 6 units to the right. So now if it's 6:30, it's 6:30 minus 6, there's your half hour. So it's a half of 125. Okay, so you get a point for that line. You get a point for this one, that one. And now to go between 7 and 9, this one's a little trickier, but not really. How much have you removed by 7 a.m.? Yeah.
This is actually relevant to your question, but on the test, so it's a real,
Right.
on the test, we have to do integrate the 1 by,
Yes, you have to come up with, the question is, do I have to do the integral? You have to come up with that answer. Can I just write this answer without doing the integral? Yes, I may do so, because this was a constant rate of change. If this was 125t, I'd actually have to integrate it. Okay? But it's constant, so it's okay. In a BC Calc, we have a problem very similar to this, but they actually have to integrate that one. Okay, what about this one? I don't have to integrate it. First off, how much snow have you removed by 7 o'clock in the morning? You've done 125, so that's there. Plus, and then you have to, well, you could either integrate or you can just write down the equation. It's 108, but it's not times t, but t minus what? 7. Because you would integrate from 7 to t of 108 dx. But it doesn't matter. The point is here, here, and here. Nothing. This is just what function would model the amount of snow that's, well, I forgot what the question was, but between 7 and 9. What was the question? Amount of snow removed. And then the last one, a lot of students just didn't get C, but they got D. And by the way, this was a common problem between AB and BC, and the BC students do remarkably better. The average is higher. I think the average for BC was like 4.5 points, where AB it was 3. But you can find all that information on the web. If you go to AP Central, you can look all that up if you're interested. It just would take me too much time to download it and put it up on my website. Okay, D isn't bad at all. How many cubic feet of snow are on the driveway at 9 a.m.? How do you find that?
Integral.
Well, how much has fallen, right? Between 0 and 6, there's a whole bunch that fell. Actually, even between 0 and 9, and subtract out how much was removed. So you got the point for the plan. Of course, that's not exactly the plan. What do we have to find? How much is falling is F of what? 9 minus H of 9. So how much has fallen? No, you have to integrate it. Right. We integrate 0 to 9 of f of t dt. I should have said the integral of that. That's not even right. But what's h of 9? How much has she removed? Okay, you guys? How much has she removed? You're close. 0 between 0 and 6. And then she removes 125 for that 1 hour. But 108 for how many hours? 2. A lot of kids missed the 2. So it's going to be 125 plus 108 times 2. And then you get 1 point for the answer. Now, how am I going to do this integral? Because I'm lazy and I'm short on time. I am short on time, actually.
What is h of t?
This is h of t. This is h of 9, but which is h of t? H of t is the integral. Okay, so we're going to go back here. Oh, that's not going to save it. Okay, clearing. It's fine. Okay, I want to go back here, and I know I did that integral before, so if you're in the new operating system, all you have to do is arrow up, but I'm not. I'm going to do second. I'm going to do second, enter. Don't press enter again. Press second, enter, until you get to what you want. It will go back about 10 keystroke histories. There it is. And I just want to integrate between 0 and what? 9. Enter. It takes a little time. Okay. If it takes a lot of time, then you know you're doing something wrong, okay? So it's, oh, well, I can just put that right there. So it's 367.334 minus 125 plus 2 times 108. I wouldn't simplify that. You should get 26. I wrote that wrong. I should have integrated from 0 to 9. I wrote it wrong. I did it right. So my integral, 1 point for that. If you do h of 9 wrong, which a lot of students did, they did 108 only one time, but they still got the integral point, and I believe we also gave them the answer point. So I got 2 out of 3. We did a follow-through error. The better I'd be about follow-through errors. Okay. Not that bad. Now look at what they did for the solution for this. All I really looked for on this is ugly. You can do that if you want, but this is all we looked for. Most people, I don't think anybody did all that stuff. They just went to the answers, or they just skipped it entirely. Yeah, but the first one is easy. It's 0, so get a point. You're gonna get a point for that. Okay. So now, you are to finish 2011. I'll find it. That one. We did start that. Do I need to start from the beginning again? How far did we get? Did we get to the derivative? I know, but we have only so much time before that exam.
I know, it's scary. I've been trying to...
Oh, we still have 4 minutes. Yeah. I always let you out a little early.
New York.
You really have 6.
I don't get that whole, nerve. So New York Twitter means it's fast or it means it lasts forever.
I don't know. Never heard of it. Okay.
Never heard of a New York
You guys, not really. What's g prime of x? Okay, guys. Oh, no, we still have 4 minutes. What's g prime of x? Okay, guys. Shh. We didn't do this. We didn't do this. Did we do this one?
We did that one.
Okay. So it's, what's G, but I still need to know G prime of X. It's 2 plus F prime of X. Okay. Determine the X coordinate of the point which has an absolute maximum on the interval. Okay, not only did we do this yesterday, we did this a while ago, because I remember doing this. I want to use the max-min existence theorem. But, shh, guys, quiet down. I want to use the max-min existence theorem, which means I would take these critical points and where the derivative is 0, so G prime of X has to equal 0, which is where 2 plus F of X has to equal 0. Okay? And I would evaluate all those. And we did that, and you can find the areas. It's tricky. So, but actually, first derivative test will also work. I'm really kind of surprised they didn't use the max-min existence theorem. But the hard part here is right here. So what's F of X equal to? Solve that. Not 2. Negative 2. So I'm going to actually use my tools here, and I want to be right on the money there, and then I'm going to do this. You do not have to write the equation of that line and see where they intersect. All you have to do is know where they intersect. And if you draw a nice picture, which I can do because I have the tools to do that, that's nice. But if you don't have the tools to do that, you might have to do that. What's the X value here? 2.5. Okay, so let's do a first derivative test. 2.5. This is going to be G prime. And remember what G prime is. G prime equals 2 plus F of X. Okay. Pardon? I actually read it off my graph. And you get the point for having the right answer. Not how you got it. You could write the equation of the line and intersect it with 2. Mrs. Hersman did that. Okay, girls. Girls. Shh. This is 0. I want to show you why the first derivative test works. Because, Adam, it doesn't always work. I might have to use the max-min existence theorem. If I take a... Shh. You guys? If I take a part of n, if I take a point to the left of 2.5, like 1, what's G prime of 1? It's 2 plus F of 1, which is clearly positive or negative?
Positive.
F of 1 is positive. I don't know what it is, but I don't really care. It's positive. And then I would like to do, girls, G prime of what? 3, which is going to be 2 plus F of 3. Right? And what's F of 3? It's negative 3, right? So it's clearly negative. Therefore, this is a max. And Artavan, why can I say that's the absolute max?
Because the value goes from positive to...
But that guarantees a relative. It's absolute because it's increasing here and then decreasing. It doesn't turn around again. It's always increasing and then always decreasing. So that will be an absolute max. Now, part C says, where does the graph G have an inflection point? What are we looking for here? Or G double prime does what? Changes sign, not equals 0. Now remember, what's G double prime?
Slow.
Yeah, what is it? It's F prime of X. Okay, where does the slope of this graph go? Change sign. It's positive here, negative there, so it's at 0. Okay, we can't finish D, but we can do part of it. Find the average rate of change of the function on that interval. What's it asking for? Artavan, what's it asking for? Average rate of change is
Average change is asking for
slope.
yeah. F of B minus F of A over B minus.
So you guys can finish that, but you can't finish the whole thing though.
Thanks for going back.
Bye. Wait, I don't want that.